Going to talk a little bit about the history of analytics. So, like I mentioned earlier, analytics in those days was more of decision support system. So you already know something, or you already feel this is how it should happen, or this is the decision I should take, and then you would go and look at you know reports and analysis and see if the numbers support your gut feeling, and then take it out from there. um, and that's pretty much what happened. It wasn't really huge, it wasn't big, there was nothing which is happening in real time and so on. And then we started talking about business intelligence coming in into the 80s, and then analytics, which is more of your AI ML, also included probably from the mid 2000s. Now I will talk a little bit about business intelligence coming in into the late 80s. So what happened was, um, towards the early 2000s, you started seeing more than just AI and ML. You started seeing companies coming up with and releasing tools where you could host your data and you could easily create dashboards out of it, which would eventually lead to insights. So you had earlier versions of click view, it was called in those days. Prior to that, you had tools coming in from IBM called Cognos. You had crystal reports, and you had business objects. You had a number of these tools, and these were probably the starting of it. And but as that point mentioned, somewhere along the line, you started seeing the rigidity. It wasn't really something which you could just do a drag and drop or get self-service analytics. And it did improve in time, but now, of course, we are met with a plethora of options. With all the new cool tools which are available in the market, including the AI/ML pieces. With regards to the chart here, this is just more for your something for you to look at, but um, you can see that how the information or the need for analytics has changed as the global economies have changed. So we started off with being an industrial economy, which really didn't need anything other than your logistical and supply chain analytics, to where more of finance came in, especially global cross-border finance started becoming big, and so on. And then finally came to seeing where analytics can be used for pretty much anything and everything today. So that's a little bit on the history of analytics, which I wanted to talk about. So this is going to be some interesting facts about data. So when I say analytics, it's analytics and data go hand in hand, because you're at the end of the analyzing data, which can be either in a structured or unstructured format, and so on. Um, so just putting out some interesting facts just for you to get an idea. I'm sure some of these you might already know, but anyway. So less than 0.5% of all the data we create is ever analyzed and used. Just put that in perspective and think about it. If we actually had the opportunity and the speed, if we can do what we're doing today with just 0.5%, imagine if I'm able to move that to 1%. Imagine what all I can do. Imagine how much better my predictions are going to be. And that's something for all of you to think about. The fact that, when we say data is the new oil, I want to make a different statement. I want to say data is the new sun, because it's always available. At any point of time you want, you can get it, and it just keeps coming and coming after that. And just like, instead of talking about oil, which is the past, we talk about solar energy, which is new, and say data is the new sun. The more I use, the better I'm going to get, the more efficient I'm going to get, and that's how I'm going to move forward. So that's huge. That itself should tell you what a massive amount of opportunity is there. Um, the rest of these are some facts and figures which have been picked up. For example, we're talking about additional income being generated. These statements were made as of 2016. I can't find any information to say whether this happened or not, but I will assure you that this is true even as of today. And if you look at things which we did not expect to be part of analytics, so we could always looking at numbers. So that's your, when you talk about analytics, somewhere people completely focus on, oh yeah, I'm processing numbers. But that changed with the advent of big data. So 2016, an estimated 1 trillion photos were taken, and whatever shared online, as you know, after that, it is all data which is searchable. So I'm sure you guys have, all of this. Like even if you go to some of the tools like Facebook and so on, if you host a photo, Facebook will immediately be able to identify all the objects in the photo. You're talking about age challenge, you're talking about facial recognition to open your phone and so on. Sky is the limit with what you can do with photos. I'll talk about more examples as we move along. And with regards to the quantum of data, let it sink in that for every second we are creating 1.7 megabytes of data, and it's humongously huge because that's the number not for the entire planet, but for every single person on the planet. So you're talking about that number multiplied by the planet's population, and then if you multiply by 24, you'll know we're just talking about a gigantic amount of data. So that's one more thing we should talk about. And the flip side, bad data is also costing US business. And again, I have only statistics for that, but bad data will lead to bad decisions or incorrect filings, let's say in taxes and so on. And they've lost about 600 billion over there. So that's something we wanted to address about the data side. The next thing I want to talk about was the types of data analytics. Um, well, I think some of you might already know this, but this is just thought I'll cover this anyway. And this kind of mirrors what has happened over the years. So if you look at the first step, it is basically descriptive analytics, and the data is just telling me what's going on. So it's a visualization, and especially in the beginning, these I mean, most people would have used Excel, and you'll know it's fairly straightforward to pull data into a pie chart or a bar diagram and just see the trend if it's going upwards or downwards, especially when the volume of data is slightly larger, more than say 100 200 rows. It's a very useful amount of data. It's a very useful tool. However, what it's doing is it's giving you a post-mortem analysis. It's not telling you anything in advance. Once that event has occurred, be it something signals being passed from a circuit, or be it sales in a particular place. Once that event is done, then you just get to have look at what has happened, and it's basically for you to just take a call as to how things went, were it good, was it not, and you'll be able to look at trends a little bit more easier. So that's part of the descriptive analytics. Then it slowly moved on to people, looking at diagnostic analytics. And here, the diagnostic analytics part, the mirror or the example of that would be slicing and dicing, which was made available through some of the tools which are out there in the market. You would have the ability, for example, if I was looking at signal strength, it's below a certain norm, then I could keep slicing the data to see where actually the problem was from, and that's what was written. It's written here, the ability to isolate all of this, and that's the diagnostic part. Predictive is where your machine learning comes into play, or any of the algorithms, where you're actually using so many things, including past trends or including any kind of data you have, to start making predictions, saying that okay, yeah, now I can actually predict what is going to happen next with what amount of accuracy. It can vary. It can be 80% accurate. It can be 60. It can be 90. But you actually get that prediction. And the nice thing is, you also know to what level your prediction is going to work, because that's how machine learning works. It gives you all those statistical numbers which you can do from there. And we've already entered into this space, but it's still not fully evolved, I would say. It's prescriptive analytics. So it is the equivalent of the machine reading that graph, telling you, okay, this is where your problem area lies. And if you continue like this is where your problem area is going to be. And if you don't want that to happen and you want to correct it, this is what you should do. So it is the equivalent of human reading, understanding, and giving you his feedback as to what you should not do, or what you can do to correct your problem, and that's where prescriptive analytics comes. So this is typically what you would find when you look at data analytics today. So now I'm coming to the next part, which is essentially, more of what I'm going to address would be more of looking at analytics as a career or analytics as a field. What is in store going forward, and how do people get into this space and what they do. So and I've just wanted to give you all a background to the extent that this is what the analytics space is all about, and these are some of the things you would experience as you go along. We can start talking about more of analytics as a career, and this the first part would obviously be the outlook for analytics this year, and obviously as we move forward. So this is what I wanted to talk about: the outlook for analytics as we're going forward. Ideally, you shouldn't talk about it in a single year. This is something which is going to go on for time to come as we move along. But we're specifically, also talking about 2021 for a simple reason that most of the companies across the world have kind of rethought what their business models are going to be like and what they are going to do, as they move forward, given what has happened in terms of the pandemic, given the fact that most of the people are now, some of them, in fact, are looking at working from home more or less on a permanent basis. We are also looking at, you know, different kinds of people, different kind of new roles coming up. Like, for example, if you talk about working from home, we have enhanced security measures on our laptops, and we have AI systems monitoring that. So you're seeing even new roles being created. So that's why I'm going to focus first on 2021. So one of the things, and we've seen this every year, the funny thing is it's just getting bigger and bigger, is that most companies will implement their AI strategy. Uh, there's been studies done by MIT, and 75% of the executives believe that AI will allow their organizations to grow and achieve a competitive edge. So it's not just a nice thing to say that, hey, I have an AI system in place. It is also finally moving towards a point where I would talk about having an AI system which can take care of mundane and routine jobs and allow us to do which jobs which have more value addition. That's one. And secondly, you can't, if you want to be competitive, and if your competitor is doing something better because he has an AI system in place, then obviously you will also have to follow suit. So all the companies are doing so, and this is something which is going to keep going, growing and growing as we move ahead. So there was a point of time in the past where we did see that a lot of companies were just toying with what they want to do, how they can essentially implement an AI solution. A lot of them had many missteps. They went ahead and hired expensive data scientists, and then they finally found that the program did not yield too many results. But what has changed after all that is that now we have come to the point where people have already implemented programs successfully, and people would be able to use those programs to essentially understand, best practices implemented within their organization. AI has also now come, not just to do some very cool project, not just driverless cars or not just drone which can avoid flying objects, but also the simple operational stuff, and that's where it's playing a big role. The next point is not really an outlook, but it's more of a commentary, and in fact, the second and third bullet should go together. A lot of people today are unaware that they are using AI platforms. It has already spread a lot, and most of the people are not even aware about it. So, what's likely to happen in 2021 is people will get more and more educated about uh, what is there in the platforms they're using, whether there's any AI involved, and so on. Um, according to that study, which in fact Pegasystems does these really good studies, They spoke about 34% of the consumers realizing that they're directly experiencing AI, but actually it's 84%. If any of you uses voice to text on your phone, you are using AI. Just remember that. So it is very widespread, and it's only going to get even more widespread as we move along. The other interesting thing is, as people get more aware about AI, and as they start understanding that what it could be used for and what are the benefits of it, it will actually at the end of the day start driving increased adoption of AI even by companies. People will, once they give it their vote of confidence, companies will be emboldened to further introduce AI into different spaces. So I want to talk about another point here. So, like I said, AI is not just for cool projects. It's not just for things like saying, "Hey, I can, program a car to move without a driver and be, as good as probably a car driven by one," or I can predict, what is going to happen 5 years from now and so on. But the essence is this: we are now looking at AI being used for the most mundane of use cases, which is great because then you are actually taking away some really boring work which needed to be done by humans. And of course, the counter argument will always be that jobs are being taken away, but this is bound to happen every time we look at these situations. For a brief period of time, you will see some amount of people losing their jobs to a machine, but very soon you will see more people getting trained, and in fact AI and ML creating more jobs in this space. So one of them is asset maintenance. This is in fact very popular in the manufacturing sector, where you can predict when machines are likely to break down. Now, I want you all to just think about this at your side. Just a very simple statement, right? It says that, hey, we can predict when the machine is going to break down. On a lighter note, I'll say that when I buy something, I myself know when I'm going to break it, so I don't need any machine to predict it. But if you just look at it from an industrial machinery standpoint, the amount of preventive maintenance which goes on and the amount of time which is lost when a breakdown happens suddenly, and just imagine that all of it is suddenly removed. All of it is now one smooth, free flowing process where I know exactly when I have to go and service a machine. And when I know that the chances of this machine are breaking down are so much higher, I'll be able to plan my resources accordingly and just imagine the efficiencies I'm going to bring in, not just the cost savings. And this is huge. And I'm just giving you one example. So just imagine the number of examples that are out there, which you can do. You will have companies finally creating a new business model wherein they come in and they assess all your assets. So let's say if you take a typical manufacturing, it would be all the machinery, it would be the factory space, it would be the elevators, it would be all of this. They completely assess, they put it into a model, and they will maintain it for you. And they're obviously going to have a very high level of success if they're using a good AI model. So just wanted to share that these kind of what is seemingly mundane is now becoming the norm. It's getting adopted, and you're going to see more and more of it as we go along. So next one is just another example, but at the end of the day, it's revenue or maximizing profits. This is going to drive most decisions, and that's what is happening. So there's another example about a French company called Danone. In fact, they're also present in India. I think they make biscuits and a few other items. So they're predicting and planning the demand for its packaged food products. So that's it's just amazing. In fact, we as a company we work with Microsoft. We actually they are vendors to us. For the last, I think, almost 3 years already, Microsoft has moved to predicting their financial numbers using AI models. They have moved away from your traditional methods of providing estimates, and they did that 3 years ago, and they're very successful. So none of these is something which is being experimented upon. These are all tried and tested. Then you're looking at things like price optimization, another area. Uh, so this is more the point I brought up simply because of how popular online shopping is getting. So you talk about customers choosing best price offers, what would be the best amount of discount to give optimum discount where you get more sales because you've given a discount, while at the same time, you're also still making a healthy profit margin, those kind of things. And it's already at work. In fact, Amazon and the fact that when Flipkart was sold to Walmart, many companies or many people said that um, Walmart has overpaid for Flipkart, which has never made profits, which has only made losses, and which essentially may not make profits in the future. But what most people did not realize at that time was that kind of money which was paid for Flipkart was only because somewhere down the line, Flipkart themselves realized that they're not in the retailing business, but they are in the data business. They're in the business of collecting data about how their customers behave, what their buying habits are. And this is just a long game which Walmart is playing, wherein they know that eventually they're going to enter India and they have the perfect means of understanding buyer behavior using Flipkart. So whatever they're losing every year is peanuts for them. It's the cost of getting this kind of invaluable data. So that's just another piece of that. Next point is something which many of you would have already experienced somewhere. You're talking about chatbots. So what they're talking about now is not just chatbots wherein if you message or ping a chatbot which is available to ask some questions, you get intelligent answers. But you could also have a proactive chatbot which would actually, call you up and say, "Hey, looks like you need a reminder system. Can I set this up for you, or would you like me to do X, Y, Z for you based on your behavior or platforms?" And it would be able to do it. They are trying to get chatbots to be less mechanical and less human-like. That will not happen to a large extent. We'll never be able to achieve that, but it will certainly get better as we move along, and it will certainly become more understanding from a human perspective as opposed to purely giving technical answers. And the last point is generate one. You all may have heard, read, seen things like this, but without doubt, the estimates will vary depending on who's looking at it about AI contributing to the GDP of world's leading economies. But just remember this, it is not a matter of whether it will happen, it is only the matter of how much it's going to happen. So, pretty much, we are looking at AI leading that next revolution. And I think the next decade is going to be a very crucial one where we're going to see so many improvements and leaps and bounds purely as we move along with the AI adoption. Okay. So I'm going to just talk, and again, this is not meant purely for your mechanical or electrical engineering, but since I believe some of a majority of you are from that space, I thought I'll put something more specifically together about these two areas. So one is about mechanical engineering. So I admit that I myself am not a mechanical engineer, but I know enough of them who I work with, and some of this is partly what I found online, and some of it came from me actually having sitting down and talking to them and trying to get a better understanding of this. So one of the things we hear is that if you look at pure mechanical engineering, technologies are stable, and the technologies stay valid. You might have different upgrades and things like that, but you're not going to have anything major. There's not going to be any major change. What you can also see is that practice can tend to get a bit boring because already you have well-defined problems, you have well-tested solutions, and you are essentially trying to follow that. That's where your experience comes in, and you're not doing anything else major over there. If you look at analytics, however, they're more dynamic, and you can have multiple approaches to solve a problem. It's not rigid in the sense how mechanical engineering is. So this is interesting because one, you see different solutions or different machine learning libraries and different methodologies coming out. Very often, a lot of it is open source, so it's not even that it's in the hand of a select few who can use it. It's immediately democratized. It's let out, and everybody can do that. And you don't have to follow a rigid approach. I mean, you have a way of measuring your solution. And if you look at machine learning, you can try multiple approaches. You can actually look at which one is giving you the best results and pick it up. So that's one area where it probably scores a lot more over mechanical engineering, and or rather, when you're just doing a comparison about how would you look at both of them and the kind of work you would do once you've completed them. And then, if you look at mechanical engineering itself, whatever you're doing over there, analytics is entering into all of those areas. So at the end of the day, my point simply moves towards being that this is not something you can avoid. It is just growing larger and larger, be it whichever space you are in. So, you know, this is just something else which you can add on as a skill set and actually enhance it. Now, if you look at robotics, there are people who are specializing in that. The earlier robots were something which would move in a straight line, be able to go left, right, and so on. But if you hear and see all the cool improvements which are taking place today, the robots can actually think, and that has come about only with the advent of AI and ML. If you look at a driverless car today, this is one form of a robot. It is actually programmed to do a certain thing, which is move from point A to point B, carrying that passenger behind without having to, causing any damage, which is in the sense of avoiding any obstacle and not having an accident. And most of the engineers already have a great knowledge of maths and stats. So, and most of you will also have the ability to pick up new languages fast. So even if you're not learning Python or R or whatever, it's something which you will easily be able to do. So at the end of it, my point is that pure mechanical engineering would not take you as far as you would um, probably want to go in terms of doing something exciting or game changing. But a combination of analytics and mechanical engineering, that's definitely going to be huge. And you can uh, pretty much work in any space once you're done analytics. But if you want to even continue in your space, assuming that you've done mechanical engineering for the love of that, you can actually enhance it a lot by moving forward. So there are a lot of similar points when you want to talk about electrical engineering also. So it's not something which is very different from what I spoke about earlier, but there are some specific points about electrical engineering here. So when you look at it, uh, you're already using a lot of statistics and analytics when any circuit boards are designed or semiconductor fabrication is happening. You will need to anyway use statistics and analytics. So what you're looking at is just taking that one more step forward. Uh, Most of the electrical engineers will have a fantastic amount of domain knowledge in that space. So you're talking about the IoT space. You're talking about the electrical uh, engineering space. You already have that. And just like I spoke about mechanical engineering, a combination of electrical engineering, especially something like IoT, coupled with the knowledge of analytics, will be something which will really take you far. Again, you already have a natural overlap with regards to knowledge of maths and stats. So these are spaces you can easily get into. They can greatly, greatly enhance your career, give you leapfrogs as you move into this space, and you can uh, also open yourself up into looking at other things beyond what you studied. So you kind of just giving yourself and setting yourself up to have multiple options and more success. Now you must wonder, why am I saying all of these things? Why am I um, you know, speaking so much about this, or is it anything to do with the course? But the fact of the matter is that I am a passionate, analytical, uh, person working in this space who has actually now almost spent close to 20 plus years in this space. I have seen it evolve, and I'm pretty much confident about where it's going to go, and hence, I would say that this is a must-have skill for everybody. If you're going to be only an analytical person, also that's great. But if you couple it with your existing knowledge, you are actually just taking your value and making it leapfrog many steps ahead. So that's what I want to talk about. There's something else I wanted to, talk about. This is basically sometimes people have this kind of confusion. I just thought I'll cover this point before we then kind of start winding down towards taking any kind of questions anybody might have. So, what do you do if you get into analytics? So you can obviously remain an engineer and you can use it. You can use statistics to basically prove or disprove your theories, which is great. Or you can even become a full fledged analytical person, taking into account your engineering background. So you can, at the top of the chain, I would say, is the data scientist. You have the data engineers and your data analysts. Now, data analysts, as per this, it's an interchangeable term. It's also known as business analyst. I would also tell you that business analysts existed for many many years in the past, and you have so many different definitions of them that it's very hard to call any one person with a particular skill set as a business analyst. So when I started out my career with a software company, I was supposed to serve as a bridge between the clients and the development team, and I was called a business analyst. I didn't really have too much of technical knowledge at that time. Then later on, it became some knowledge of business, which would help to recommend, and technology combination. Then you would also take the classical definition of a business analyst, where somebody actually comes in from a consulting perspective, looks at different businesses, and is able to analyze and tell you, whether A's option is better than B option and so on. But data analysts are people who essentially are the ones who are, understanding the data, uh, making it available for processing, and ensuring that it is governed properly and it's kept secure. So if you're pulling the data in to use, data is not perfect. There's going to be gaps in it. There's going to be all kinds of issues with it, and that's where the data analyst will be an expert in how to pull data, be it large volumes or small volumes, how to manipulate the data, how to transform it, and how to also plug the gaps, reduce the errors, and make it completely usable for any kind of analysis. And then we come as the come to the data engineers. You also have DBAs and architects. But this is more just people who are able to process large data sets and focus on coding. So essentially, you're taking all the data which the data analyst has given you, you're writing code to process that, and you're coming up with the output finally. Um, so essentially, that's what you're doing. It is, I would say, in a sense, I would also call them as a machine learning engineer. And it would also be that people who have a great amount of expertise in uh, coding and who understand machine learning libraries can also be in this sweet spot. And then you come to the data scientist. So data scientist, he kind of encompasses all of this. Ideally, classically, some people talk about the data scientists being able to process the data themselves. But today you have people who are pure play data scientists, where they know about which is the right model to be used. They're able to also create those models, and not just that, they have the ability to use statistics to tell you whether the output of the model is right, it's wrong, it's usable or not. And how do I run this model on a consistent basis to ensure that whatever results I'm getting out of it is actually an actionable insight? So that's where probably the role of a data scientist is slightly enhanced. So these are all typically the options you have in front of you if you were to look at getting into analytics in a space. And yeah, that's about it. So I am not going to you know continue too much more. On my talk, I'd rather leave a few minutes if anybody has any questions, putting it out on the chat bot. Happy to answer them. But hope I was able to give you a very high level view about why analytics is going to be so big and what it would take to get into this space.